circle. We actually defined this on our notes the other day on 6.1. Okay, we said that the description or definition of a circle was you have some center, and the circle is made up of all points that are equidistant from that center, right? So this is all points on a circle are same distance from center. Okay, so for this figure here, what would be the center of this circle? B. So the name of this circle would be circle B, right? And for the notation, I kind of had to go into this box a little bit, but remember we just have that symbol for circle followed by the letter. Okay, next they ask us for the characteristics of a radius. What is a radius? Very good. So a segment from the center to any point on the circle. Very good. So in this drawing here, what would be an example of a radius? BA, Right, this segment BA. We also could have chosen BC or BD, right, as long as it goes from center to the edge. Good. Okay, what about a diameter? What's a diameter? Right, it has to be on the edges or the outside of the circle, right? So its endpoints are on the circle. That's the definition of a chord, right? So it's a chord that goes through the center, is what we said the other day on our paper, okay? A chord that goes through the center. Okay, what would be an example of a radius here? Good. Okay. Then we have central angles. So central angles we talked about yesterday. What did we say a central angle was? Yes, it is going to be between two lines, and it has to not just be going towards the center, it has to be the center, right? So the vertex of the angle has to be the center of our circle. So this would be an angle with a vertex at the center. So what would be an example of a central angle here? Good. Okay. We also talked about arcs yesterday. What did we say an arc was? Right, a portion of the circle. Very good. And remember that you guys previously talked about if you were going around the outside of a circle, that was called the circumference, right? So it's basically a portion of the circle's circumference. And how do we name an arc? Right, very good. So, for example, what would I name this arc? Right. So I would put CA with the symbol above it, right? This is a minor or a major arc? Minor. How do I name a major arc? Right, we have to put that third letter in there, right? Okay, very good. Okay. All right, then we have a semicircle. What's a semicircle? Half circle, right? And it measures exactly how many degrees? Good. All right, so what would be an example of a semicircle over here? Very good. Okay, what's a minor arc? Right, an arc that's less than 180. Good. Okay, so besides the one we already mentioned, CA, what would be an example of another minor arc here? Good. All right, then we have a major arc. What's a major arc's definition? Very good. So, arc measuring between 180 and 360. Okay. What would be an example of a major arc here? Okay, good. Okay, and then lastly we have adjacent arcs. This is another one we talked about yesterday. What's an adjacent arc? Right, right. Yeah, they're going to share the same what? A point, right? Whenever we name them, they'll have a point in common. Very good. So two arcs that share 1 point. Good. Okay, so what would be an example of two adjacent arcs here? Perfect. Arc CA and arc AD, because they share the common point of A, right? Okay, good. So we have reviewed ourselves on the vocabulary we've gone over thus far. If you'll flip over onto the next page, we're now going to talk about finding arc length. Okay? Talking about arc length, first of all, it does say that we are going to leave our answers in terms of pi, if you see that up there at the top. So we're going to leave them in terms of pi because, as you guys know, pi is an irrational number, a decimal that would keep going, right? So if I do actually multiply something by pi, eventually it has to be rounded, right? It can't go on forever. And as soon as you round, it's no longer an exact answer, and we want to keep our answers as exact as possible, all right? So on each one of these columns, they've given a few random answers, right? For this top row, they gave us the radius and the central angle. Next row, the diameter, measure of the angle, and so on. So we are going to use the information given on each line to fill in all the other boxes. So first, we're going to need a formula for arc length. So whenever we were talking about arc length, or arc measure yesterday is how we were dealing with it, we always measured in degrees, right? So many degrees out of the whole circle. And we know the whole circle is what? 360. So every time I was setting something up, especially in those problems where we were cross multiplying, it was x out of 360 degrees, right? Okay, my x from yesterday is the angle that we're looking at, right? That's what we call the central angle. So whenever you're doing these problems, it's going to be your central angle over 360 degrees. But we're wanting to convert that into arc length, which is some part of the distance around the circle, which is basically circumference, right? Does anybody remember what the formula for circumference is for a circle? Any guesses? 2 pi r, right. So 2 pi r is the whole circle, right? We're just looking for a portion of that circle. So, just like yesterday, we're going to set up a proportion that we could cross multiply. So we're looking for the arc length of some specific section out of the whole circle, which you guys just told me we find with 2 pi r. Okay? And now, if you know the central angle or the arc length, then you know what you could plug in to find the other piece that's missing, right? So this is going to be the formula we use to find arc length, or if you're given arc length, you could go back and find the central angle, okay? So let's see here. On the first one, they give us that the radius is 6. So let's see if we can fill in that first row. So if the radius is 6, what is the diameter? 12, right. 6 times 2, diameter must be 12. Okay. Then they ask for the circumference. So you guys just told me circumference was 2 pi r, and what is r? The radius, which is 6. So what I really have is 2 pi 6. We're not going to multiply by pi, it said, right? Leave it in terms of pi. But I can multiply the 2 and the 6, which would give us 12. So 12 pi is our circumference. Okay. Then it says they want to know the measure of the central angle. Well, in the picture, we can clearly see that the central angle is a what degree angle? A 90-degree angle. Good. If you didn't know that, then we can tell that it's a quarter of it, right, with how it's marked in there. And so you could do 1/4 times 360. That works too. But yes, we know by the marking that it is 90 degrees. Okay, they told us right here that it was a quarter. So if we didn't see that marking there, we could have used that to help us find the central angle. So they said what they did here was central angle over 360. So they did 90 over 360, and it's simplified to 1/4. Okay. So then the last thing they want is the arc length for AB. Okay, so we said that to find that, we use that formula we wrote at the bottom, right? Which was central angle. What's our central angle? 90, right? Over 360. So 90 over 360 was equal to arc length. That's the part we don't know, right? So arc length over 2 pi r. And what did our 2 pi r simplify down to? 12 pi. So basically, this part is my x, or my unknown, right? So if I multiply this direction, I've got 360 times, you could call it x if you wanted to, you don't have to write out arc length. Okay. So 360x equals 90 times 12 pi. So I would have 90 times 12, because we're not actually multiplying by pi, right? What is 90 times 12? And then we would have to divide by 360, right? So what would we get when we divide by 360? 3. So my arc length is 3 pi. So whenever you're solving these problems, it tells you do not multiply by pi, only multiply the actual numbers, okay? So 360 times x and 90 times 12, tag your pi on at the end, all right? Okay, let's do another one. Okay, on this next row, it did not give us the radius, but we do have that the diameter is 10, right? Well, if the diameter is 10, what does the radius have to be? Right. Okay? So then what would my circumference be if the radius is 5? 2 pi 5, right? 2 pi 5 would simplify to 10 pi. Good. All right, on this one, they did give us the central angle, right? This is the simplified central angle. So this would be 45 over 360. What will 45 over 360 simplify to? 1/8. So the reason that they have us doing this step is because that's the first part of my ratio over here. So I technically could use 1/8 instead of 45 over 360 to keep my numbers smaller. Okay, it's just a simplified version of the same thing. All right, so I would have 45 over 360, or 1/8, is equal to that arc length, we can call it x, over 2 pi r, which we said was 10 pi. Okay. So I have 8 times x and 1 times 10. So what is 10 divided by 8? Right. So my answer is 1.25 pi. Or if you had 45 over 360 here, you got bigger numbers when you multiplied, but you still got the same answer when you divided. Okay. All right. Next row. They told us that the radius was 12. So what would that make our diameter? 24. Which would make our circumference, good. Okay, and then they told us that the central angle was 120. So central angle over 360 would be 120 over 360. What will that simplify to? Very good. And again, you can put either one of these in as the first fraction over here. Okay? So I'd have 1/3 is equal to arc length over our 2 pi r, which we said was 24 pi. So what is our arc length for this one? Very good. Okay. All right, on this row, they did not give us they did not give us radius or diameter, but they did give us circumference, right? Okay, this number, if you guys notice, is always the same as the circumference, right? Because to get that number, we have doubled the radius. So what would my diameter be for this one? 5.4, which then means my radius must have been, very good. Okay, they gave us that the central angle was 60. What does 60 over 360 simplify to? Very good. So then I have 1/6 is equal to x over circumference, which was 5.4 pi. So I cross multiply. 1 times 5.4 is just 5.4, and it's equal to 6x. So I'm going to have to divide by 6. What do we get for our arc length this time? Good. 0.9 pi is my arc length. All right, we got one more on this row. So they gave us that the diameter is 16, so what's my radius? Good. And what's the circumference? Good. They gave us the central angle, so I put that over 360, which is going to simplify to what? 112. Guys, remember your calculator does that for you. If you type 30 divided by 360 in your calculator and then hit math, enter, it converts it back to a fraction for you in simplified form. Okay? All right, and then we use either one of those two fractions. So I got 112 is equal to x over my circumference, 16 pi. What do we get here? Right. 1 1/3 or 1.3 repeating pi, or 4/3 pi, right? Typically, this is going to be the answer that they're looking for if they tell you not to estimate. Okay. All right. So now we know how to find arc length. Flip it over one more page. and now we're going to talk about sector area. So on all of these problems, what we were finding was how long it is from points A to B. So how long that piece was, how long that piece was, how long this piece was, right? That's what circumference is the outside edge. Well, when we are looking at area, we are now finding the part inside, right? So I'm looking at how much space is taken up on the inside. Okay, so for my sector area, it starts out the exact same way as it did in our last formula. We're looking for only a portion out of the whole circle, right? So my formula is central angle out of the whole circle, 360, just like last time. But this time, instead of looking for arc length, we're looking for sector area. Anybody remember the formula to find the area of a whole circle? The circumference, you guys remembered, was 2 pi r. Any guesses on what the formula is for area? Close, pi r squared. We dropped the 2. Good. Okay, so pi r squared is the area of the whole circle. We're just looking for a portion of that area, right? Okay, so let's see here. Oops. Hold on. I'll just have to move it. We'll look at that later. Okay. All right. So, I know that my pictures for some reason were messed up here. I don't know why it keeps doing that because I'm saving it as a PDF. But anyways, so in that first column, they gave us the radius, right? The radius is 5. So what do I know that the diameter is going to be? Good. Okay, and then we just said that to find the area, our formula was pi r squared. And we're going to leave it in terms of pi. So what is that going to simplify to? Good. Okay, then for the measure of the central angle, they said it was 90 degrees, right? Okay. So for this portion, I would have 90 over 360, which again is going to simplify to 1/4. All right, and then for that last column, sector area. So remember, we could use either one of these fractions because they're equivalent. Okay. So 1/4 is equal to sector area, we'll call it x, over pi r squared. And this is what we got for pi r squared, right? So over 25 pi. So we cross multiply, and we have to divide. What do we get for sector area? 25. You can do this one as a decimal too, since it is an exact decimal, that's okay. It's when we have those repeating decimals that we don't want to do that because we eventually have to round. Yeah. All right. Okay. Second row, they gave us that the diameter was 14. So what was the radius? 7. So what would that mean our area is? Good. Okay, the central angle was 30 degrees. 30 over 360 simplifies to what? Very good. And you can use either one of those fractions in your last column. So 1/12 is equal to x over our area, which was 49 pi. We cross multiply, and what do we get here? What are we going to leave it as a fraction? Right. It doesn't simplify down. So we leave it as 49 over 12 pi. Okay. Next row. Radius was 3. What's the diameter? Oh, sorry, 13. Thank you. Sorry. The radius is 13, so the diameter is good. Okay, if the radius is 13, then what is our area? Very good. The angle was 140 degrees. Oh, thank you. The angle was 140 degrees. 140 out of 360 is going to simplify down to what? Good. And you can use either one of these fractions as the first fraction over here. Over that area, which was 169 pi. Okay, so we have that 169 times 7 divided by 18. So this is another one of those repeating decimals. If you are trying to get an exact answer, you can leave it as a fraction. If the problem doesn't specify, I don't mind if you do decimal or. If we leave it as a fraction, it's going to be a pretty big fraction, right? So that would have been, what, 1,183 over 18 pi. Or I'm okay with, if they don't specify, just go a couple decimal places. So you could do something like that. Sorry, yeah, is that right? 65, yeah, 0.72. Okay. All right, on this next one, they tell us this part. 289 pi is the area. So if my area is 289 pi, then what did my radius have to be? 17, very good. Which means my diameter was 34. Good. All right. Then my angle, 75 degrees, 75 over 360 simplifies to good. And then we just set up our ratio. So 5 over 24 is equal to x over that 289 pi. Okay, again, it's going to give us a pretty big fraction or a decimal. I'm okay with either one as long as the question doesn't specify what they wanted in. So what would this one be as a decimal? Good. All right. Okay, and then for this last row, diameter is 20, so what's radius? So what's the area? 100 pi. Okay, 25 degrees, 25 over 360 simplifies to good. And 5 over 72 is equal to x over that 100 pi. So as a decimal, what do we get here? 6.94. I had to erase that earlier, but central angle over 360 is equal to sector area over pi r squared.